This video will describe the standard operating procedure for the bioreactor experiment in the Lafayette College Unit Operations Lab. Before operating the bioreactor, it is important to be aware of the following safety precautions. When running the bioreactor, operators must wear standard personal protective equipment at all times. This includes long pants, closed-toed shoes, a lab coat, and safety glasses. Additionally, long hair should be tied back to prevent it from getting caught in the impeller. If the operator is wearing loose, long sleeves, the sleeves should also be tucked away. This experiment also involves the use of a pressurized nitrogen tank. Operators should ensure that the nitrogen tank is properly secured to the wall before beginning the bioreactor operation. Another safety concern to consider with this experiment is related to the use of an impeller within the bioreactor. Objects may get caught in the impeller, which may cause damage. So during operation, it is important to keep anything that could get caught in the impeller or the exposed rotating shaft away from these pieces of equipment. This includes hair, long sleeves, hands, the air line, nitrogen line, and DO probe. Use extra caution to ensure that the DO probe is kept away from the impeller, as this can damage the probe. Finally, spills may occur during operation or in filling the tank. Spilling during operation is usually the result of a high air or nitrogen flow rate or an excessive impeller speed. Operating conditions that may cause spills should be avoided in order to prevent water from entering electrical sockets. Any spills should be cleaned up immediately. In order to start the bioreactor experiment, fill vessel R100 with enough fluid to submerge the impeller and sparger. This amount can range between 0.5 liters and 1 liter of fluid. Do not fill the bioreactor to the point where overflow could occur during operations. The motor and sparger apparatus should then be screwed onto the reactor vessel in order to properly secure it. To ensure that the vessel is well mixed, set motor controller MC100 to the desired speed. The motor speed should be set to a value in which water does not escape the vessel. To remove any initial oxygen from the water, begin by placing the nitrogen line into the bioreactor. Make sure that the nitrogen line touches the bottom of the vessel. Next, place the DO probe into the water, ensuring it does not hit the impeller. The DO probe should have been previously calibrated. If it appears the probe is not calibrated, notify a lab instructor. To begin the flow of nitrogen into the bioreactor, open the valve at the top of the nitrogen tank, V2, about a quarter turn. Then, slowly open the flow indicator valve until bubbles appear in the bioreactor vessel. Be sure not to open the valve too much, as it will cause excessive bubbling and could lead to a spill. Continue to sparge with nitrogen until the DO probe value reaches approximately 0% oxygen. Close valve V2 and remove the nitrogen line. To begin the first trial, set MC100 to the desired impeller speed. Open the air valve labeled V101 and set FC100 to the desired sparging rate. Upon setting the sparging rate, start the stopwatch to begin data collection. Record the oxygen percentage from the DO probe every 10 to 20 seconds. Continue recording the DO probe reading until sufficient data is collected to create a curve of oxygen concentration versus time. The graph of oxygen concentration versus time should stay fairly constant at first and then should increase linearly. If there is a large increase in the concentration of oxygen on the DO probe, it is likely the result of a bubble hitting the surface of the DO probe. If this occurs, the trial must be redone. In order to mitigate this issue, slowly swirl the DO probe in the bioreactor to ensure bubbles are not caught on the surface of the probe. Upon the completion of the trial, close valve V101 and begin the sparging procedure once again until the oxygen percentage returns to about 0. Repeat this procedure for each trial, appropriately changing the desired airflow rate and impeller speed. To shut down, close valves V101 and V2. Turn off MC100. Unscrew the motor and sparger apparatus from the vessel and empty the vessel in the sink. This has been the standard operating procedure for the bioreactor experiment in the Lafayette College Unit Operations Lab. To learn more about the equipment in the Unit Operations Laboratory, watch the related videos on the Lafayette CHBE YouTube channel.